In this video, we're going to build a simple waiting line simulation model. Once you open this application, AnyLogic, choose File from the top main menu and go to New, Model. You can give the model a name, any name you want to use. And looking at this window of this application, you will notice that there are 3 columns. On the left side, you can switch between this tab called Palette and Project. If you choose Project, you can see all the models you are working on. Let's switch to Palette for now. You will see that on the very left, there are many different icons. And mostly we're going to deal with this icon that looks like a clock, and that is the icon for the process modeling library. Now we're going to start with building a flowchart to represent the waiting line system. We need to find a component called source in the process modeling library. So let me drag this icon into the canvas in the middle, and source represents where customers are coming from in the waiting line system. If you click on source and go to the right panel, which shows you properties of the selected component, you will see that there are a few things we can manipulate. To make it easy, let me maximize the property window. First of all, we need to decide how to define arrivals. As mentioned in class, a convenient way to model variations is to define a distribution for the interval times. So from this drop-down menu of how we define arrivals, let's select interval time. And then in the next field, we need to specify the distribution of interval time. So the default is shown as exponential distribution with the rate equal to 1. For now, I'm going to change the rate to 0.25, and the default unit measure is measured by seconds for this interval time. Right? In other words, this rate 0.25 is the number of customers arriving per second. Now let me restore the original size of the property window, and then go back to the left panel, go to palette. After source, we need to have a component called Q. So drag this component to the canvas and move it closer to the source component, and automatically those will be connected together. Let's further adjust the position of the components after they are connected. So this is the queue, this is the waiting line, and as we all know, this is where customers are going to wait. On the property window, you can specify the capacity to determine the maximum number of customers you can host in the waiting space. Here I'm going to check this checkbox called maximum capacity. So it means that we're going to assume that the number of people you can host in the waiting line is going to be as large as the system this software application can handle. And then that's the waiting line, and next part is to model the service. We need this component called delay. This actually models the service area, because once you finish waiting, you have to receive the service before you can leave. In other words, customers are further delayed because they need to get the service. If you want to make it more intuitive, in the right panel, in the property window, you can change delay to service area. Now let's further change a few things about the service area. First of all, we can change the capacity from the default value 1 to 2. This represents how many servers do you have. We can also change the delay time distribution. By default, we have triangular distribution. The meaning itself is not so important for now. We only need to know that it's just a kind of distribution. But to replace it by something we're familiar with, let me change it to exponential distribution. Exponential. And we need to specify a rate. So let's set the rate as 0.125, and that's the service rate per second. Okay, so that's the service area. After you get a service, you have to leave, so we need to model the exit. So this component called sink represents the exit of this waiting line system, and we don't need to really set anything in the property window for this sink, because it just represents that customers are going to leave after they finish the waiting. So let me click on source again, the entrance, and actually let me change the arrival rate from 0.25 to 0.24 because we do need to make sure that the overall service capacity is greater than the arrival rate, as one of our main assumptions for all the waiting line models. And basically, this waiting line system is built. Now, next step is to add some visualization of how customers arrive and where do they wait, and eventually they will be leaving. To do that, again, we stay in the process modeling library, but we're going to look for a path which is right there in the space markup section, and this is going to be representing the waiting line itself. So I'm gonna select this queue component again, and in the property window now we can specify the agent location, and the agent location is right here. Let's put the agents on the path, and we further need to include a component to represent the service area. So the component we're going to use is the point node. If you want, you can also use a rectangular node or the other node. I can make it slightly larger, and then that's going to represent the waiting area. That's going to represent the service area. Now we're going to select the service area once again in the flowchart and specify the agent location of the service area to be the node we just added. Now we can actually try to see if the model was built successfully. So go to the area near the top of the application window. There's an icon here right to the left of this green triangular play button. So let's click on this icon first to build this model we have created. If you don't see any error message, it means that everything is correct. And then we can click on this green play button to launch the simulation. So let's wait for a few moments for the simulation model to start. Now, simulation is launched, and you will see that in the flowchart we actually have some numbers near every component. Right to the To the right of the source component, this number 3 represents that 3 customers has been generated. For the queue component on top, it shows how many people are in the queue. Currently it's 0. Now it's 1. And in the number on the left represents how many people have entered the queue. The number on the right represents how many people have left the queue. Basically the same for the service area. For the sink, the number represents how many people have exited the waiting line system. And we also see those color dots on the path and in the service area. Every dot represents a customer. And right now, the simulation speed is kind of slow, but we can actually speed up the simulation clock to make it faster than the real-time clock. So let me click on the plus button near the bottom. We can make it very fast. So I think the fastest speed is 1,000 times the real time. Okay, now we see that things are very fast. Okay, so that's how we run the simulation model. But as you may remember, the focus of the waiting line model analysis is more on how to measure the average waiting time, average time in total, average queue length, average number of people in total in the waiting line system, etc. So right now we don't have any of those, so we need to further include some components to help us measure the performance of the waiting line system. How do we do that? Well, this time again go to the very left. There are different icons, and there's one of them that looks like a histogram chart. So it's called the analysis library. So let's click on this icon, and there will be a few things we can choose. Okay. And later on, we're going to use some of those charts. But before that, let's return to the process modeling library once again, because if we want to measure things like waiting time and the total time spent in system, we actually need to have two more components. One is called time measure start. So drag this icon to the middle of source and queue, to the middle of the line connecting source and queue. And we also need time measure end. Drag this icon and insert it. For now, I'm going to insert it between service and sink. So now we have a pair of time measure start and time measure end. Slightly adjust the position of the components so the text actually do not overlap. If I put the time measure start before the waiting line and time measure end after the service area, then we're measuring the time between the moment a customer enters the waiting line and the moment the customer finishes service. That's the total time spent by a customer in the system. If you put time measure end between queue and service area, then you are simply measuring the waiting time. Now we have to tell the application tool that we need to pair those two components. So select time measure end, and then in the property window, click on this plus icon, and you can choose the time measure start module we have created earlier, and this will tell the model that we actually are making those a pair. Now, once again, select time measure end and right click, create a chart. We select the distribution chart, and a chart is appearing here. This is going to be modeling the total time distribution. Every customer have a different duration of total time in this waiting line system. So if you collect data for many customers, you will have a distribution. Let me select this chart, and in the property window, intuitively it's a good idea to change the title of the chart. By default, it's distribution. We can call it in this case, the system time distribution, because it's the total time in the system. And we also want to select this checkbox that says show mean, because other than the distribution of the service time of different customers, we also want to calculate the mean time of this distribution. Okay. So that's the chart represents the distribution of the total time spent by customers in the system. And in this chart, we're also going to be able to read the mean value, which is the average total time for customers. There's a couple of more charts I want to use. Go to the very left. As mentioned, we're going to use the analysis library. There are many icons, many tools, and charts there. You can do some experiments by yourself. Right now, I want to focus on two things. One is the simple bar chart. So let me drag the bar chart to the canvas area and place it somewhere we can find space. So now once again, in the property window, we can change the title, and this chart is going to help us to see the average queue length. And so I'm changing the title. We also need to change the value, and the value should be the average queue length. So we're going to look at the name of this waiting line component, which is queue. So name of the waiting line, which is queue dot stats size. So that's the size of the queue, and dot mean. So that will help us get not just the size of the queue, which is the length of the queue, but also over time what is the average length, the mean value. And that's another chart. So let's actually try to click on the build icon to see if anything is wrong. There's no error, so everything looks okay. And lastly, I want to demonstrate how to use the time plot. So let me click on this icon of time plot and drag it to some blank space. And this chart of time plot will plot the number of customers in a certain area of the flow chart as time goes. The number of customers there will be changing. As we all know, this variation, things will be changing. So you will see a time plot, and you will see that the number is changing over time. I will change the title to number of customers in queue. Right? So that's the queue length. But this is different from the previous chart. The previous chart is the average queue length. But this chart is going to show you the real-time queue length at any specific time moments. And the value is going to be queue dot size. So this time it's simpler. And don't forget this pair of parentheses. And that's pretty much done. So let me click on this build icon and then further click on this green play button to run this model and wait for the pop-up window. So the simulation started. Everything looks okay now, but the simulation is going to be very fast if you very slow if you are using the default time. So let me once again speed up the simulation clock to make it, now it's 500 times faster than the real-time clock. Now, as we can see, everything is changing because there's a variation, there's dynamics in the waiting line system. But let me further increase the speed. But after a while, what you can notice is that the shape of the distribution of the total time experienced by different customers start to become more stable. And you see this green line in the middle, that's indicating the average length of the queue. And here, this number here kept changing, but now it becomes sort of stable. That's the average number of people in the queue, or the average queue length. My apologies, it's not the queue length. This chart is actually the distribution chart of the total time spent by customers in the waiting line system. Right? So this green vertical line level, which is the same as the green number below the chart, it's the mean time spent by customers in the waiting line system by different customers. Now it becomes relatively stable, and the mean time spent by customers is somehow between 85 and 90 seconds. It's still changing because there's always variation, but it becomes stable. And this chart here in the bottom left, that's the average queue length. Okay. And the last chart shows you the time plot. It shows you the real time queue length at any given moment, but because time moves forward in the simulation, we are actually having this plot moving rapidly. So if you pause it, you will take a snapshot of how many people are there at a given time moment. Alright, so that's basically this simulation model. And what you can do if you want to estimate average queue length, average time spent by customers in the system, etc., is that you run the simulation, make the speed kind of very fast compared to the real-time clock, and then after the distribution shape becomes stable, the average queue length becomes stable, you can pause it and take a snapshot. And then you can use those numbers here. This number represents the average time customers spend in the system, and this number for the second chart represents the average queue length, how many customers on average in the waiting line itself. So those are how you can estimate different performance measures as some kind of average for a waiting line system.